Can you imagine life on Mars? How would it sound if we tell you that for the first time we're not that far away to have the chance to walk on the surface of Mars? We got the chance thanks to Elon Musk and his hard work and dedication. The SpaceX CEO is building a starship that will take people to Mars. Anyway, the trip will take months in space, so Musk had to come up with a new plan to protect the people, so he came with the new Artificial Gravity Starship. Watch this video to the end to see SpaceX's new insane Artificial Gravity Starship. SpaceX has already had a successful landing with the SN-15 prototype, so the spaceship is a step closer to reaching the ultimate goal of heading to Mars. However, a lot of people are not believing in Elon Musk's dream to make living on Mars possible, but the good news is that Musk will not stop trying to make his dream possible. We've all seen science fiction movies where a group of astronauts were sent to space. After leaving the atmosphere, the crew landed on the moon, Mars, or other planets. But this is not the case in real life. The astronauts in movies are just walking through the spaceship or space station. Is this even possible in real life? The answer is no, we can't afford this luxury, and this is the reason why Musk is building the new Starship. In the movies, artificial gravity exists, even if it doesn't exist in the actual world. The new Artificial Gravity Starship will be unique. It's capable of lifting more than 100 tons to orbit. This is essential since many tons of cargo must go ahead of the colonizers. It contains systems to keep humans alive. We shouldn't forget that Mars is a harsh environment, so changes have to be made. SpaceX has to supply materials, water, and food. But why does Musk have to create artificial gravity for Starship? Scott Kelly spent a year in space as part of NASA's twin study. He found readjusting to life on Earth to be severe, aiming to prevent health effects on the crew of the members where the long-term effects are unknown. We saw NASA's astronaut Scott Kelly struggling to walk after a year in space. This should be a lesson for everyone that wants to have a Mars trip. The passenger will have a workout routine and the finest treatment available in 50 years of space medicine. Recovering from protracted zero-G remains a huge physical struggle. When the gravity is gone, our bodies will realize that there is no need for muscles to keep us functioning normally. But there are two elements that can decrease the risk. Any type of communication between Mars and Earth will have a 20-minute delay, so in case of emergencies or equipment failures, the crew has to be able to handle everything on their own. The estimated trip time is 120 days. The gravity on Mars is only 40% that of Earth. Mars is 140 million miles away. This means once the astronauts are on Mars, they can't resupply the resources in order to survive. The astronauts who travel to space now complete ultrasound to monitor how their bodies change in response to the off-Earth environment. The Human Research Program is testing how they can improve food formulation, processing, packaging, and preservation. On the Mars trip, the spaceship will face 3 different gravity fields. The first is the Earth's gravity field, which is approximately 10 newtons kilogram. In the 6-month period, the astronaut's body will have to adapt. According to the Human Research Program, the trip can affect hand-eye coordination, balance, movement, and sense of space. It impacts the muscles, bones, and heart as well. Without gravity, a person's bone density drops by 1% each month because the body isn't working against the force. So for the first flights, astronauts are needed because there's still a risk, especially for non-professional astronauts. This can't go in the right direction. And now Elon Musk comes back. Artificial gravity is the creation of an inertial force that mimics the effects of a gravitational force, usually by rotation. It is thus the appearance of a centrifugal force in a rotating frame of reference, the transmission of centripetal acceleration via normal force in the non-rotating frame of reference, as opposed to the force experienced in linear acceleration, which by the equivalence principle is indistinguishable from gravity. So Musk wants to build spinning ships. This requires a special design. The rig needs to roll around the ship's long axis. The acceleration depends on the rotation speed and the radius of the ring, but the Starship is not constructed with these issues. The ship's long axis is the 160-foot nose-to-tail axis with a 30-foot diameter. This means a 15-foot radius for acceleration, so the spaceship will have a decent acceleration. But with this new design, the problems are coming too. Having a rotating Starship makes orienting antenna precisely very hard, creating communications challenges. As the antenna rotate, they'll continually lose and regain signal as the rotation moves the antenna out of the orientation range. Columbus took 3 ships to search for the West Indies. When one ship encounters problems, having another platform and additional resources to work from to correct the problem is invaluable. It'd be better if the Starship uses a second, fully crewed and packed Starship as the counterweight and act as its counterweight in return. In order to refuel the nearly empty Starship once it reaches orbit, the current plan is for a second tanker unit rendezvous tail-to-tail with the empty Starship to transfer fuel. This model establishes that the Starship design has an aft mating collar for refueling. It has been widely speculated that the refueling process would be inertial rather than pumped. That's to say that the fuel and propellant transfer would likely occur simply as a matter of the entire assembly thrusting gently into the orientation of the tanker, causing the fuel to fall into the empty Starship. While SpaceX is the only company trying to solve the problem, they're not the first to find a solution. For that, we need to go back to 1903. Konstantin Tsiolkovsky, a Russian and Soviet rocket scientist, was exploring the exploration of outer space through rocket devices. He discovered that the horizontal speed required for a minimal orbit around the Earth is 8,000 ms, 5 miles per second, and this could be achieved using a multi-stage rocket fueled by liquid oxygen and liquid hydrogen. In the article Exploration of Outer Space Utilizing Rocket Devices, it was suggested for the first time that a rocket could perform spaceflight. Konstantin came with some ideas for missiles and considered the use of liquid rocket engines. He designed a spaceship in 1903 which had 3 main sections. The pilot and co-pilot were the first section. The second and third sections held the liquid oxygen and liquid hydrogen needed to fuel the spacecraft, but the results of the first publication were not what Tsiolkovsky expected. No scientist appreciated his research, so in 1911 he published the second of the work, Exploration of Outer Space Through Rocket Devices. Here he evaluated the work needed to overcome the force of gravity, determined the speed needed to propel the device into the solar system, escape velocity, and examined the calculation of flight time. After the articles, he finally got the reputation he deserved 111 years later.